Okay, we're going to continue our unit on relations and functions this week. Last week we looked at what makes something a relation versus how can we tell it's a function. We also looked at stating domain and range. This week we are going to focus on real-world graphs for these first couple of days and then look at equations and how we can make a relation or a function from those equations. Today what we're going to focus on are graphs that represent situations we might see in the real world. So a couple of different things will be given to you. Either you'll be given a graph and you have to describe what you're seeing in the graph, or you will be given a scenario and we have to come up with what the graph would look like. One thing to make sure that you guys realize is there's not just one right or wrong answer, so you might come up with a graph that looks slightly different than somebody else. As long as you're following what the word problem is giving you, both of your graphs can be correct. We're going to start with this first example here, where they're giving us a graph. We have time on the bottom, seconds going on our y-axis, and we're told here the graph shows the height of a roller coaster during a ride. So that's why we have height going along the side. The higher up the graph goes, the higher the roller coaster is. And then when it drops down, that means the roller coaster is falling down. So what we are coming up with is we are going to explain what we see in the graph. So we can see right here, the ride starts, and the roller coaster just kind of pulls forward a little bit before it starts going up. And then it gets to a highest point. Once it hits that high point, it turns and it makes a large drop. And so we are going to explain exactly that. We explain what we see in the graph. So the roller coaster left the gate and climbed up a large hill before making a large drop. So the roller coaster goes up, gets to the top of the hill, turns and makes a drop. Then we can see that the roller coaster goes up again, but not quite as high, and then it makes another drop, but it's a much smaller drop. So we explain that. The roller coaster climbs up again, and makes a smaller drop. And then we can see here that there is one more time the roller coaster goes up, makes one more drop, not quite as big as the first one, and then the ride is over. And so again, we explain exactly that. There's one more hill, the roller coaster makes one more drop, a little smaller than the first, and the ride ends. So instead of just saying our graph goes up, then down, then up, then down, then up, then down, we have to explain it in the context we're given that this is a roller coaster ride. So the roller coaster starts, it goes up, then makes a large drop, goes up again and makes a smaller drop, goes up one last time before making one last drop, and then the ride is over. So that's what they mean when they're asking you to explain these real-world graphs, to describe what you are seeing. Another situation that we'll have in this section is that we will be given a scenario and then we have to come up with what the graph would look like. And this is where you might come up with a graph that's slightly different than somebody else's, but as long as they're both describing the situation, both can be correct. So if we look at this one, we are looking at snowfall. In a single day, it snowed lightly during the morning and then heavy for the rest of the day. And then they're telling us here that we need to graph time on X and snowfall on the Y. So we're going to label that. Going along the x-axis, we have time. And then going along the y-axis, we have our snowfall. All right, let me get these so that they're not filled in. All right, and then going back to our graph, or going back to our word problem, it snowed lightly during the morning. So it started snowing here, and it was snowing, but not too much. And then it says that it snowed heavily the rest of the day, which means that all of a sudden it's going to start snowing a little bit more. And that's our graph. That's all we have to do. We just show those two differences where here it started snowing lightly, and then it started snowing a little more heavily. All right, looking at number 3, Mia bought a painting. The value of the painting dropped by 25% after 1 year. Then it increased in value over the next 5 years, and it reached a value that was twice what she paid for it. We're going to graph time on the x-axis and value on the y. So here we have our time, and that's in years. And then on the y, we're going to have the value of the painting. All right, so since Mia is buying a painting, the value is going to start up somewhere on the graph. So I'm going to start it here. After 1 year, it dropped by 25%. So if I kind of make these little marks here, after 1 year, it dropped 25%. So now the value is here. 1 year, we're down 25%. Then it increased in value over the next 5 years, reaching a value twice what she paid for it. So if I'm here at 4, that means eventually it's going to be worth this line up here at 8, and that happens 1, 2, 3, 4, 5 years later. We just connect those, and there's our graph. So we bought the painting, the value dropped, but then the value increased again. All right, let's look at one more together like this. Number 4, a basketball was dropped out of a window on the 2nd floor of the school. Each time the ball hit the ground, it reached a height that was half the previous, and it continued until it landed, finally stopping on the ground. So we're going to label. We're graphing time on the x and then distance on the y. So let me move this up to the y-axis. And turn it a little. All right. So then we graph our example. We drop the ball out of the window, so it hits the ground. It goes up halfway, hits the ground again, halfway, and it's just going to keep doing that until eventually it's back on the ground. Now yours might not go up exactly half, but as long as it's pretty close to where it should be, then your graph is correct. All right, so I'm going to have you try out number 5. All right, try and graph a situation. Jace is speeding on a highway. He gets stopped by a police officer. He's given a ticket, and then he continues down the highway. We're going to do time on X and then speed on Y. So he's speeding, he gets pulled over, then he continues driving, hopefully not as fast. And then try out number 6, paying attention, we're graphing the games on X, and then total yards on Y. All right, moving on to number 7. Alice drives a school bus. On her morning route, she stops every block to let students on. We're going to graph time on the X and then the total distance on Y. So time and our distance. All right, so when she starts driving, and then she stops to let kids on. She starts driving again. Now she stopped to let kids on, driving, and it just continues. Our distance keeps increasing, but then we've got this little space here where she's stopping to let the kids get on the bus. And then last example like this, Ray starts his workout by running on the treadmill. So when we're running, we know that we're going pretty fast. His heart rate rapidly increased, and then it remained high during this run. After the treadmill, he lifted weights, and during this time, it says his heart rate is increasing and decreasing. So along the bottom, we're going to put the time of his workout. Along our y-axis, we'll put our heart rate. And now if you think about it, our heart rate is never at 0. If it's at 0, we've got a problem. So we're going to start our heart rate somewhere in the middle. When I'm running, my heart rate rapidly increases, and then it says that my heart rate kind of increases and decreases as I go. And so there's our graph of this situation. Again, it doesn't have to be perfect. We just have to show what's happening in the scenario we're given. We have a rapid increase, and then we have decreasing and increasing. All right, and then last example on the notes is matching a graph that we're given to a situation. So in this case, we've got 3 different people, Carrie, Luke, and Mason. They all receive the same allowance. Carrie spent a small amount in the first half of the month. Then she spent the rest in the second half. Luke steadily spent all his money through the month. And then Mason rapidly spent all his money. So we're going to try and match each situation to what we see on these graphs. So since I know Luke steadily spent his money, that means that his graph just increases at a constant rate. So this graph represents Luke. Carrie spent a small amount and then spent the rest of the money later. So here we're spending just a little bit, then we're spending more, so this is Carrie. And then our last kid here, Mason, he rapidly spent everything. So he spends all his money, and then he has nothing left to spend. So this graph represents Mason. All right, so this is what we're going to work on the next couple of days, matching real-world graphs to these real-world situations. Now you guys can go ahead, and we're going to work on starting the assignment that goes with this section.